Good evening, everyone. Thanks for being with us today. My name is Marisa Gomez, and I'm the Public Programs Manager at the Santa Cruz Museum of Natural History. And our mission is to connect people with nature and science to inspire stewardship of the natural world. And we're grateful to be connecting with so many of you today. We're currently closed to the public, as you may know, and while many of our primary modes of connection that we typically employ are on pause, we're really thrilled to have found new methods during this time to connect in meaningful ways, especially today when so many of you joining us are tuning in from out of state, maybe even out of the country, which is something that we wouldn't have dreamt of a few months ago. So we're really excited. So if you haven't yet, please take a moment to hop on the chat and make sure to select all panelists and attendees so everyone can see your answer. But we're curious to know who you are, where you're tuning in from, and also if you could let us know what your relationship is with art or science or both. I know that we have many friends, colleagues, and followers of Jen joining us, as well as artists featured in our current exhibition of science illustration, The Art of Nature, which you can view online now. And also other friends who have other reasons for being here. So please help us get to know you and use the chat for that. Today's program will last about an hour or so, and after Jen finishes her formal presentation, she and I will go through the chat and the Q&A together. So please drop your questions there throughout. You can, again, either use the chat function or you can use the Q&A function. Lots of things to play with here today on Zoom. Also want to take a moment to thank the many of you who contributed monetary donations while registering for today's program. As a fully independent nonprofit organization, we depend entirely on community support in order to steward our collections, increase environmental literacy in our schools, offer opportunities like this for our community to connect with experts and deepen their understanding of nature and science. So just thank you very much for supporting that. And without further ado, we're going to get into the main event. I want to quickly pull up something to share with you before I introduce Jen. Here we go. So Jen Christiansen, we're really lucky to have her joining us today. She's the senior graphics editor for Scientific American, but she also has a history here in Santa Cruz. And for the artists out there joining us who are in our science illustration show, The Art of Nature, she also has been exhibited at the Santa Cruz Museum of Natural History. I don't want to take too much of what she's going to be sharing with you, but we're really grateful to bring her back, whether virtually. I believe she's joining us from Connecticut today. But since her time here in Santa Cruz and since her early studies where she studied both art and geology, which is a favorite of mine and of the museum's, she's gone on to do great things with Scientific American, National Geographic, and others. So we're really thrilled to have her joining us today and to hear her perspective on how visualizing science through illustration and graphics is impactful for understanding science. So very, very thrilled for that. And without further ado, I'm going to welcome in Jen. So you should be seeing her now. Hi, Jen. Do you want to unmute yourself?
There we go. Somebody had to do it. It's over now.
Got that out of the way.
Yes. Thanks for having me.
So thrilled to have you here today. And I haven't been looking at the chat. I'm kind of curious to see what people are sharing. Got lots of science illustrators, infographers, maybe that's the way that you enunciate that one.
Infographers, infographers, tomato.
Yeah, we've definitely got some out of the countries, out of towners, so we're really happy with that. So thanks for connecting us with all of these new members of our community, Jen. And take it away. Can't wait to hear what you have to share.
Oh, sure. Thank you so much for that introduction. Let's see, I'm going to try screen sharing now. Let's give this a shot. Hopefully it'll just take a second. Let's see. All right. I think we're good. Yes, okay. So let's see. There we go. So as Marissa mentioned, I do have a little bit of a history with Santa Cruz, and with the Santa Cruz Museum of Natural History. I'm afraid I'm going to date myself a little bit by revealing this, but as a grad student at UC Santa Cruz 24 years ago, I was involved in an early form of the exhibit that is now known as the Art of Nature at the Santa Cruz Museum of Natural History. So it's a real treat to be involved in this way now. And if you haven't checked it out yet, I encourage you to visit the virtual exhibit website. The current version of the student show that grew out of that shared exhibit from decades ago can be seen in virtual form here. It also includes video artist statements, which are really neat to see. So in this time of isolation, I'd like to use this hour to get folks thinking about connections and lessons that can be shared across disciplines. In particular, disciplines that cluster around these words: art, nature, science, illustration, design, visualization, graphics, and communication. For example, where does the illustrator end? And the information graphics designer begin? How does data visualization fit in? And what does science have to say about the design decisions that we make? But first, I should provide some context. The thoughts to follow are very much rooted in my own experiences. This is a bit of a reflection upon what I've observed over the course of my career as an art director, a journalist, and an artist. These are musings related to my journey, rooted in the world of publishing, with shout outs to some of the resources and communities that I've found helpful or thought-provoking along the way. So here's some background for context on what has shaped my own point of view. I was trained primarily in traditional or physical media. Here's one of my first published scientific illustrations: ink drawings of hydrothermal vent shrimp mouthparts. It's one of the products of a few summers in college working in a crustacea lab at the Natural History Museum in Los Angeles. But I did get a chance to dabble in the digital realm starting in the late 1980s with the Commodore Amiga. I then shifted over to tablets and virtual drawing at Smith College, where my instructor led exercises like blind contour figure drawing, with the model in the middle of the room, our backs towards our monitors, and Wacom tablets in our laps. Sadly, but perhaps not surprisingly, I don't have clear examples of my earliest digital work. And if I did, it would be hard to access them, as we've gone through several generations of disk storage types since then. I was able to track this photo down in a college print publication. I find it pretty telling that one of the few artifacts of my early digital work is a photo of an image on a screen printed on paper that I still have at my closet. Now you might notice that the subject of my illustration here is a conch shell. I can't recall the species, but I do recall taking reference photographs in a geology field course. As much as I loved my art and design classes, I also loved my science classes. I resisted choosing one discipline at the expense of the other and pursued a double major in geology and studio art. Then a scientific illustration graduate program at the University of California, Santa Cruz caught my eye and allowed me to officially merge those two disciplines under the tutelage of Ann Cottle, Jenny Keller, and Larry Lavendahl. Instead of dedicating myself to a single scientific line of research, I'd help make other people's research accessible to wider audiences through a visual language. That program is now hosted by California State University at Monterey Bay. Now, at first, to me, that meant observation and representation. And I developed illustrations in the spirit of these examples by Robert Hooke and Maria Sibylla Merian. But over time, my interest shifted from illustrating objects towards developing explanatory process and concept diagrams, more in the spirit of this moon phase diagram by Al Biruni. And I shifted more and more towards trying to show things like change over time, like this series that shows the feeding behavior of a monarch butterfly caterpillar. My interest shifted from object representation to process representation. I entered the publishing scene after graduate school as an intern in the art department at Scientific American, thanks to my mentor, Ed Bell. This is my first illustration for the magazine. It's a watercolor cockroach. I still have that in my closet too. My internship turned into a full-time job, and as my role shifted from artist to art director, I found myself setting my watercolors and pens aside and turning to the computer as my primary tool. In 1998, I left Scientific American to work as an assistant art director and then a designer at National Geographic, all the while growing as an art director and learning about print production by some of the best in the business. Then I established a freelance science communication business focusing mainly on magazine and book projects. In 2007, I returned to Scientific American, where I'm now the senior graphics editor. Today, there are two of us on the graphics team, Amanda Montanez and me. We art direct all of the information graphics in the magazine, from data visualizations like the sample on the left by Pitch Interactive, to illustrated explanatory diagrams like the sample on the right by Sherry Sinnen. Occasionally, we develop the final images ourselves, but most often we hire freelance artists and manage the project. We also manage digital versions of all of the graphics for web and phone viewing, and Amanda develops graphics specifically for the web environment, mostly for news. But I'm going to remain rooted in print examples for what I'll be sharing today. Editorial illustrations like these examples by Maria Corte Madigan and Jay Bent are art directed by other people in the art department. What's the difference? Well, by my definition, information graphics are illustrations that are built on a foundation of research, and they exist primarily to convey information, whereas editorial illustrations are thematic illustrations that are inspired by the text and entice readers to engage more fully with the magazine's content. For example, for an article on the microbiome, the team at Brian Christie Design developed an opening image that's not a literal representation of the concept, but instead nods to the idea of a human as being defined by the microbes within. They're telling a story with visual symbols and thoughtful composition. This is not an information graphic. Instead, it's a metaphorical illustration that nods to the theme of the text. Within the article, they shift into information graphics mode, using visual symbols and thoughtful composition to convey very specific information that's rooted in research. Now, this is not an editorial illustration. It's an information graphic or explanatory diagram, at least by my definition. Now, some artists are comfortable in both of these worlds, but this is where I reside when it comes to my own illustration work and in my role as a graphics editor. I tend to think of information graphics as a continuum, with figurative representations on one end and abstract representations on the other. In the world of science visualization, you could argue that that full continuum can also be referred to as data visualizations. After all, essentially all of our work is rooted in data collection at some stage of the process. From bone length measurements in dinosaur reconstructions, to meticulously documented laboratory experiments that build up to a more complete understanding of processes like photosynthesis, to representations of mathematical expressions like Feynman diagrams, to straight up plotting of the raw data itself in chart form. But outside of the world of science visualization, it may be more useful to think of the continuum like this. When I flip through old issues of Scientific American, it strikes me that many of the regular art contributors worked across this full spectrum. Regular contributor Bunji Tagawa's body of work astounds me. Here's a small example to give you a glimpse at the breadth of his skill set. It ranges from figurative depictions of objects to medical cutaways, technical schematics, and data visualizations. But as a graphics editor at the magazine now, I find myself maintaining kind of discrete freelance pools for each of the different points along the continuum. Now, perhaps this is an artifact of my own biases, but when I flip through old issues of Scientific American, it occurs to me that this increased specialization might also be in part due to the shifting tools of each of those areas. When the primary tool for developing representative illustrations, explanatory diagrams, and data visualizations for print magazines was pen and ink, an artist could become an expert in using pen and ink, then explore different methods of problem solving in each of those areas. Here are more examples from Bunji Tagawa, again from organics to technical cutaways, abstract representations of processes, and number-based plots all in pen and ink. As desktop publishing became ubiquitous and digital rendering tools diversified and became more widely available, it seems to me that the simple act of choosing a primary tool starts to define the edges of the artist's scope. As an art director, I find myself specifically looking for 3D artists to build physical objects, like this example by Don Foley. And I look for artists like Tammy Tulpa, who hone in on composition and the flow of information by iterating with tools like Adobe Illustrator for explanatory diagrams. And data designers that build solutions with code for visualizing large data sets, like Jan Willem Tulp. Each of these tools, mediums, styles, and genres takes lots of time to learn and tend to favor different portions of the continuum. Many of the conferences I attend and the communities that I engage with seem to reinforce those divisions by focusing on the tools. And it seems that artists that span more than one of these orbs are harder and harder to find. Perhaps that way of thinking about things is a little overly dramatic, because the reality is probably much more like this. And perhaps this is a completely natural and fine state to be in, particularly since the primary tools for these different subdisciplines have bifurcated over time. And perhaps there isn't value in trying to force discrete clusters to reconnect. After all, some of my favorite Scientific American graphics are the result of bringing together different artists, plucking experts from each of those groups and matching them up to result in a final image that draws upon all of their strengths, not forcing one artist to excel in all areas. For example, I love to take an artist who can develop spot illustrations with a stylus or pen and pair them up with an artist who can custom code data visualization solutions, as in this example by Moritz Steffener and Jillian Walters. But it also applies to graphics like these, in which different pieces of the full story are simply better served by different types of visualizations and areas of artist expertise. That said, I argue that even if you don't have the desire to work across the full continuum or the time to dedicate to becoming proficient across the full continuum, there's a lot to be learned from each of those clusters. And I'd love to see more cross-pollination of ideas between them. I think we'd all benefit if things looked more like this. It would be even better if things looked like this. I'm not arguing that everyone along the continuum should learn how to code, or that everyone along the continuum should paint from life. I'm arguing that we can and should learn how science visualizers from across the full spectrum think through and solve problems. In that spirit, I'd like to share some of the things that I've learned from individuals within these different clusters. Let's start with representative illustrations. Here are 5 key lessons that I've learned largely from this community. Lesson number 1, every detail is worthy of intense attention and care. Every feature should be observed and considered. For a graphic about the impact of mosquitoes on public health, artist Emmy Smith demonstrates that yes, a lineup of different mosquito species can, in fact, be visually interesting and informative, and reinforces the idea that different mosquito species are connected to different diseases in humans. My colleagues were skeptical at this plan at first. They worried that the mosquitoes would all look the same, but the careful and exacting eye of artist Emmy Smith revealed the variations between them. It's clear here that every pencil mark is intentional and considered. To my mind, the thoughtful and meticulous rendering of every single detail here is a challenge to me as the reader to, in return, carefully and thoughtfully consider each insect depicted. Lesson number 2, get your eyes on the subject matter. For an article on the American burying beetle, artist Kelly Murphy knew she'd need to render the insect from a variety of angles. Existing images online made for great references for top-down views, But in order to get a better look at the mouth parts, and in order to more accurately represent the beetle in different positions, she tracked down a specimen at the California Academy of Sciences and spent some time photographing it from all angles. Lesson number 3. If you can't get your eyes on the subject matter, consider making an approximation. Artist James Gurney's scenes are incredibly convincing, in part due to the dimensional models he develops to inform his composition and lighting. Lesson number 4. There is power in photorealistic and hyperreal renderings. As Ed Bell wrote in 2010, quote, "Artist Ron Miller takes us on a journey to 8 of the most breathtaking views that await intrepid explorers of our solar system. The scale of these natural wonders dwarfs anything Earth has to offer. What might we see and feel if we could travel to these distant domains? The artist's eye, interpreting data from probes such as NASA's Cassini, which is now exploring the Saturnian system, and Messenger, which has flown by Mercury 3 times and goes into permanent orbit next March, allows us an early visit to these unforgettable locales." End quote. Lesson 5. There is power in non-photorealistic renderings. Here, artist Carol Donner edits out non-essential details and employs transparency to create an aesthetically appealing and clear look at the heart. Unlike Ron Miller's objective in The View of Saturn, the goal here is not to help the reader experience the environment. The goal here is to represent the behavior of an object. As Ian Sook and his co-authors wrote in the Journal of Biocommunication, quote, "Medical illustration, by its very essence, requires some degree of simplification and idealization of the subject. It is the role of the illustrator to visually educate the reader regarding a complex biomedical procedure, structure, or process in an aesthetic and efficient manner." End quote. Let's start to slide over a little more into the realm of information graphics and explanatory diagrams. Lesson number 1. There is power in knowing when and how to distort the physical form of your subject to best serve the informational content. This particular example was rendered by one of my favorites again, Bunji Tagawa. It is a variation on a classic schematic representation of the cardiovascular system. Rather than get caught up in the details of a human figure, the information is streamlined in a way that highlights the closed and circular flow of blood through the system. Lesson number 2. Composition is key. The artist should be acutely aware of how they are guiding the reader's eye through an illustration. Here, John Grimwade very intentionally guides the reader's eye through the page with spare line work, selective color, and setting up the flow of action in a way that reinforces the flow of information. Lesson number 3, text is vital. It's just as important as images. Here, artist Emily Cooper presents an elegant set of 4 Atlantic Ocean views. Labels help orient the readers to a certain degree, and you can piece together parts of the story here. We're looking at how winds and the Gulf Stream relate to temperature, but it's hard to sort out what the take-home message is. That's where text comes in. The headline and annotation subheads immediately provide context. The graphic aims to explain why winter is warmer in Europe according to 4 different models. Through that lens, the reader is now primed to compare and contrast those 4 models. Lesson number 4, welcoming gestures in the form of relatable details or moments of joy can engage readers. Designer Nigel Holmes excels at including touches of humor and humanity to explanatory graphics. Here, he manages to inject life into a graphic about group theory and the mathematical underpinnings of symmetry. But the figures aren't simply decorative. They help reinforce the concept of the cube rotation around different axes. Lesson 5, context is key. Your audience and the goal of the information graphic should guide both content and style. For an article on artificial photosynthesis, a scientist provided us with the reference material on the left. It's a schematic of the device they had developed to mimic photosynthesis. The image is perfectly serviceable for the scientist's peers and the context of a scientific paper. But for a consumer magazine, we needed to not only engage non-specialist readers, but also help them kind of more immediately see the parallels between the technology and natural photosynthesis. Our version is on the right. Note that we introduced a photosynthesis primer of sorts for basic context, something that might trigger a memory about somebody's mind about their high school biology textbook, for instance. And the context of a consumer magazine granted us the freedom to go a little bit more playful with the rendering style, which made it a great match for botanical artist Sherry Sinnen. Let's continue sliding more over into the realm of abstract renderings and data visualization. Lesson number 1, fully explore your data set, then explore it some more. For a graphic about changing bee populations over time, data visualizer Moritz Steffener started by exploring the raw data in forms ranging from bar charts to tables and heat maps to network diagrams, all in the service of examining the shape of the data through many different lenses. The data sketches on the left are just a small sample of the total. Only after he had thoroughly examined the data in different forms did he start to hone in on what final form might serve the data and our readers the best. Lesson number 2, it's okay to embrace complexity. But when presenting people with a complicated, layered, and rich look at a topic, always provide the reader with the tools they need to interpret the visualization. Here, for an article on the evolution of mythical stories, Design Studio Accurate presents many levels of data in a single visual. It's a complicated and rich data visualization, rooted in a complicated and rich data set from a scientist. Some folks might argue that we're requiring too much effort on behalf of the reader. There's not a quick way to read this at all. However, we set things up with a clear how to read this figure key, using informal language that you might use when talking to a friend through a graphic. The idea being that once the reader dedicates a bit of guided effort into learning how to read things, they can then pop over and see a few annotated main takeaway points, then explore further on their own. This type of approach also allowed us to present the full data set, rather than distilling things down into an oversimplistic summary. Lesson number 3, novel forms can draw a reader in. For a piece on when babies are born, data scientist Zan Armstrong and visualizer Nadi Bremer collaborated to develop this custom solution for the magazine. The information here could be presented in a more classic and linear chart form as well, for sure. But I doubt it would have captured the reader's attention nearly as well. The circles are not only captivating, but they also reinforce the cyclical nature of the data, like a clock. As with the complex example, however, the reader needed to be given a clear guide on how to read the graphic. And when the final product inspires someone to rebuild it with Play-Doh, you know you've captured people's imaginations. This remake was created by Amy Sassal as part of her daily Play-Doh visualization experiment. Lesson number 4, but sometimes a straightforward line graph or bar chart is best. For this chart nugget on bias in coronary artery disease research, there was no need to push the boundaries or try to be clever. A straightforward and simple, familiar chart form was all that was needed. Lesson number 5, Your source data is not objective, nor is it complete. There are many great resources on this topic, including the book Race After Technology and Data Feminism, but I think it's worth nodding directly to a few specific writings here. As researcher, artist, and software developer Catherine D'Ignazio writes in her post, "What Would Feminist Data Visualization Look Like?" Quote, "What's the issue? Feminist standpoint theory would say that the issue is that all knowledge is socially situated, and that the perspectives of oppressed groups, including women, minorities, and others, are systematically excluded from general knowledge. Until we acknowledge and recognize that power of inclusion and exclusion and develop some visual language for it, we must acknowledge data visualization as one more powerful and flawed tool of oppression." End quote. And on the topic of missing data, artist and researcher Mimi Onaha writes, quote, "Data sets are the end product of classification systems, the clean outputs of intentional orderings. Data sets point to their own contrasts, specifically the things that we haven't collected. And if it is true that we make sense of the world through exclusion, then perhaps there is a special type of meaning to be found in the things that we leave out." End quote. And on the topic of decolonizing data, Abigail Echo Hawk, director of the Urban Indian Health Institute, says, quote, "I recognized that the systems that we're currently working towards evaluation, data collection, technology, science, and the way that we looked at the health of Native people weren't serving my people because they didn't have the indigenous framework. I always think about the data as story, and each person who contributed to that story as storytellers. Each person who contributed to that data as storytellers. What is our responsibility to the story and our responsibility to the storyteller?" End quote. These ideas have made me approach projects like this one with both more trepidation and clearer vision. For this article on infectious diseases several years ago, we hoped to give folks a sense of the global state of things. How have infectious diseases impacted public health over time and space? Art researcher Amanda Hobbs was a huge help on this front, doing a large literature survey and identifying some of the known pitfalls. We ended up using pretty standard and authoritative sources for the bulk of the spread here: the Centers for Disease Control and Prevention and the World Health Organization. But even seemingly well-meaning authoritative sources can't control for data collection variations over time and space. And data collection methodologies are developed by individuals with inherent biases. So I made sure to read the data documentation carefully, avoiding known pitfalls and making note of when methodologies changed. That helped guide decisions like the time interval we used, as well as guiding some on-chart annotations and captions. We also ran things by a few experts in the field for a reality check. But I think I failed to really help readers understand that this sort of data is not infallible. But we at least left a pretty clear crumb trail with the source citation so that it is possible for folks to inspect the original data for themselves, although we can't expect readers will do that at all. They shouldn't have to. I think that the team of us that worked on this story about maternal mortality a few years later did a much better job of responsibly framing the data, starting by showing the global maternal mortality rates provided by two different authoritative sources: the World Health Organization in the dark red color, and the Institute for Health Metrics and Evaluation in coral. The values don't match, especially in the United States. We're immediately showing and visually underscoring that there are some data collection disparities in play. The data is far from perfect, but there are still lessons to be learned from it, perhaps just as many lessons about the data collectors as the data contributors. If you're a regular reader of Scientific American, you may have noticed that we're not creating national scale data visualizations of COVID-19 cases. This is in part due to the misleading nature of the data. Testing availability and reporting has fluctuated dramatically over time and space, resulting in a lot of caveats. Here's a great blog post on that topic. Some publications that have large investigative data teams are in a better position to address those caveats responsibly. Scientific American is better positioned to address other aspects of the topic, such as the inner workings of the virus itself. And now 4 bonus lessons from across and around the continuum. Lesson number 1, question design rules. Many of us can probably recite often quoted rules from well-known designers and authors like Edward Tufte's proclamation that, quote, graphical excellence is that which gives to the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space, end quote. But how do we know that's true? And if it is true in one context, is it true in another? Perception scientists are steadily chipping away at some of these sorts of questions. I'd encourage you to check out the Data Stories podcast for interviews with some of those researchers, the blog Multiple Views, and Kennedy Elliott's post entitled 39 Studies About Human Perception in 30 Minutes. Lesson number 2, share. I'm often struck by how generous the data journalism community is when it comes to sharing visualization best practices, story ideas, techniques, tools, and resources. If you're interested in learning more, a great place to start is the Computer-Assisted Reporting Program of the Investigative Reporters and Editors Organization. Lesson number 3, create spaces for dialogue like this one. Thank you, Marissa and the museum. The intersection of science and the fine and performing arts is a bit further outside of my personal wheelhouse, but I'm excited to continue to learn more about how artists and performers engage with broad audiences in different kinds of spaces. And I'm interested in trying to figure out how to apply those lessons of engagement within my magazine work. For more, I'd encourage you to check out the SciArt Center, an online platform and event organization that promotes cross-disciplinary collaborations, art exhibits, and events. And for more information about the performing arts and science, see Jamie McRae's talk at the SciViz NYC conference in 2017, as well as one of the communities she references in that talk, Superhero Clubhouse. As I mentioned a moment ago, I'm trying to figure out how to apply some of their lessons of audience engagement and dialogue within my own magazine work. Which brings me to lesson 4, we're stronger together. I'd like to tip my hat to platforms and communities that encourage idea and tool sharing. I've grown a great deal by watching the data visualization community problem solve in real time on Twitter, watching panel discussions about technology and interaction through the lens of ethics at I/O Festival, listening to talks about the open web at OpenVisConf, learning about how visual journalists from around the world solve problems at the Malafié World Infographic Summit. The list is too long to call them all out individually here, but I've included some of my favorites in this Google sheet. It's a page that contains a list of references that I've built in response to specific requests from students, scientists, and artists interested in learning more about science visualization, all the way from illustration to data visualization. On that note, there's certainly already some evidence of lesson crossover between communities. For example, the idea of using annotations in information graphics has infiltrated the data visualization world, as demonstrated by tools developed in 2017 by data visualization engineer Susie Liu. Her work facilitates annotation integration for charts built with code. And you could argue that the photoreal versus non-photoreal dynamic in scientific illustration is mirrored by the complex versus simple dynamic in data visualization. But I think we still have so much to learn from each other, especially when it comes to things like the challenge of visualizing scientific uncertainty, a communications challenge that cuts across all areas of science, and thus all areas of science visualization. At the magazine, we often work with academics and research scientists, communities that often fall back on conventions like error bars. And all too often, I just faithfully reproduce those error bars, shown here in gray, figuring that adding a few labels might be enough to unpack meaning for the reader. But do we lean too heavily on conventions like error bars that lay audience might not understand? What if data visualizers took inspiration from scientific illustrators, and scientific illustrators took inspiration from data visualizers? Maybe we could work together to figure out more intuitive ways to represent statistical uncertainty. I think it would be exciting to see how qualitative solutions in general might inform quantitative solutions and vice versa. So with that, I'll end with a request. I hope that you'll join me in developing ways to strengthen ties and share lessons across disciplines. Thanks so much. Here's that Google Sheet URL once more while I try to figure out how to stop sharing my screen, and we'll go back to Marissa. I'll be right with you. There we go.
Great.
Hey,
Thank you
hey.
so much, Jen. And for everyone joining us today, we're going to continue talking for a little while. And if you have questions, please feel free to put them in the chat, and I'll keep an eye on it so that we can discuss them if there's anything that you'd like to share with us. But Jen, I'm wondering if you could speak a little bit more about the distinction between your team and maybe the people writing the articles. I think that I kind of had this assumption that a science visualization team would be maybe producing images after an article is written and basing it off of the article. But I kind of feel after your talk like that's not maybe the way that it really goes, and that your job is to really take that data and find meaning in it. Is that the case, or is it kind of more fluid than that?
There's different scenarios for sure. A lot of our work at Scientific American is text driven. So we are often working with a manuscript, at least an early draft. Usually it's not edited yet, as the point of inspiration. And so the art team reads those manuscripts and determines what might be the parts of that story that are best told with images instead of words, and we build an art plan from there. Sometimes, like the maternal mortality article, that was a very kind of graphics-driven piece where it was 4-page article, and we wanted it to be very data-centric. So in that case, the visualization and the text kind of were much more kind of evolving together, and we brought the author on board after we had started doing research of our own and realized that we needed help from an expert to help guide us, because there was so much out there, and to help give us a reality check on what a lot of this data really means. So in that case, it kind of happened a little bit more cohesively. So it really depends on the article for sure.
Yeah, is that so your team is kind of more broad, whereas the people who are writing the articles and gathering the information might have a little bit more, might be more specialized?
Yes, in a way, there are more text editors at the magazine than there are graphics editors, or there are more text editors than the entire art team as well. And our text editors tend to have areas of specialty, space, neuroscience, evolution. And many of them have a PhD in that discipline as well, or at least a master's. But our art team needs to be a little bit broader because we're kind of working across all of the areas. And we also work with journalists and scientist authors. So some of our articles are written by the scientists who do the research themselves, and others are written by journalists who can take a few steps back further and kind of pull together a lot of research together in a different kind of story. So every project's a little different. Yeah.
I guess so that makes me think too about your background. So you have a background in geology, back
Yes.
and I'm curious that geology was one of the things that I was thinking about in terms of areas that kind of I think of as having conventions for how they are represented. So geologic maps, like there are certain colors that you use, and there's certain keys and scales. And so I'm just curious how that plays into your work at all. With the magazine, is it kind of a free-for-all? Like, do you get to decide what the best way to create a visualization is given the topic, even if it is something that generally has conventions built in? Or are there certain things that you feel compelled to stay true to those conventions?
Yeah, that's a very insightful question, because as a geologist, when we get a story, or I'm not a geologist, I study geology. Well, I guess that makes me a geologist, right? Anyway, I fall back on some of the conventions too without questioning them when I'm starting to, if we're doing a phylogenetic tree, like I'll start to set it up a certain way for a paleo article. And I often need to kind of step back and also rely a little bit on my colleagues to say, are we falling back on that convention because it's a useful way to show that information, or is it just because it's a shared language among scientists, much like jargon? And we do a lot of work to shake jargon out of the text. Words that have very specific meanings within a community are great, and they're very useful within that community. But when you're trying to speak to folks who don't know that language or interact with folks who don't know that language, you can't be using those really specialized words. So I try to do the same thing with images, try to kind of step back and think, is this visual jargon? Does this not mean something to someone who doesn't know that visual language? For instance, like in biology and microbio, there's often something that inhibits a process is shown with a bar on a line as opposed to an arrow. So something that activates it was with the arrow, and then something that inhibits is kind of like this. And it's kind of shorthand, and it's so easy to fall back on that because it's like, okay, there's a visual solution for this, I'll just use that. But what about people who don't know what that means? So you kind of need to take a step back and look at it again. Because we work a lot with scientists, and we rely on scientists as consultants, and they're being very generous with their time and expertise, it's sometimes a delicate balancing act because you want to honor how they feel is correct. But you also need to respect that your audience is different than often their audience is. So it's a little bit of a trade-off sometimes, but yeah.
Yeah, I guess that also got me thinking about, so you're kind of talking about your own biases of your own understanding, and then constantly having to place these tools to help you question your assumptions before you move further. And I really appreciated all that you had to say about bias in general in data, and then also in data visualization, because there's the two sides, which you really, I think, did a great job going into, that it's, you're a line of defense against that and how you visualize the data, but then there's also another line of defense in terms of how it's collected. And and I'm curious if you have anything more to say about what sorts of mental tools you use or systems that you have in place, or maybe research that helps you determine if if something that you're working on is biased, and what that bias is, and how you can be anti-bias almost to an extent. And if that's a goal of yours, to look at those moments of where you can actually like you were saying with the error, where not only are you going to do your best to not be biased, but you're going to actually put in there, this is bias right here, and placing it, or or displaying something in a way that's like purposefully confronting that.
Right. Yeah, it's hard, isn't it? Because in science, I'm always taught, what does the data say? The data is objective and is truth, right? So it's been kind of an ongoing work and just trying to figure out and doing a lot more readings and figure out how to kind of come to terms with the idea of so much of what we report on is rooted in data. So how do you kind of keep the whole house of cards from falling down? But I think it really just comes into looking at everything with a critical eye and asking who collected the data and why originally, because that can start to tell you a lot of things about the parameters. So I think that's a good starting point. But I think it's just to always just kind of question the data, kind of make sure you're reading as much as you can about the methodologies. And whenever I'm in doubt now, I reach out to an expert in the area. We did an article recently on Alzheimer's. There was a whole special report, and the data wasn't really, a few different data sets were conflicting with one another again. And so we just reached out to a few experts and said, hey, can you explain why these data sets aren't matching up in terms of rates of the disease? And, can you tell us a little bit about why these two data sets don't agree? And then you can, often just somebody who's working in that can tell you very clearly why those, what the distinction is between the two. And that can really inform how you frame it, which data set you use, or if you decide to do both, or if you decide that it's better not to show that particular bit of data.
Yeah, which is what you're kind of getting to with the COVID data that that you all were presented with that you didn't feel
Right.
was appropriate for you to share out.
Right. Well, and some people are equipped with larger data teams where they can really dedicate the time and energy into helping shake all of that out and help readers understand what they're looking at. But it's a big job, and you need a large team to do some of that. So it was just a decision that we made. It's not necessarily, I'm really glad that some people are diving into it and showing it. But it's the kind of thing you have to kind of be thoughtful about before just kind of putting it out there in the public.
Yeah, that kind of, someone in the comments said, it seems like so much time, research, and work goes into visualizations, but many people in the general public consume scientific content digitally and expect things to be timely and topical. How is the process different in producing visualizations for things like blogs or news stories that have quick turnaround time, which I think kind of speaks to what we were talking about too?
Yeah, no, that's a super insightful question too. So our Amanda, my colleague, does much more of the work on the news cycle, and her pieces tend to be a little bit more focused on not single data sets, but they tend to be less kind of epic. If something needs to happen very quickly, you kind of want to focus in quickly, as opposed to trying to compile everything that's ever been done on the topic and tell a huge, big, broad story, especially if you have a really fast turnaround time. So figure out what nugget of information is best told visually and do it efficiently and kind of cleanly in a small space.
Mm-hmm.
Yeah.
Yeah. So it might be that the magazine might tell that story in a different way, but it won't necessarily involve your team heavily.
Yeah.
That's also something I was wondering again about COVID. But you did mention there were some organizations or magazines or other publications that were more suited with their teams set up and with their resources to be able to share out data in a way that maybe wasn't quite working for Scientific American and your setup. Do you happen to know offhand or have any references for us on particularly good visualizations of COVID data?
Oh, that's a good question. So the New York Times just, I think yesterday, released a beautiful map-based piece on the spread of COVID over time. That was really quite amazing. I believe it was the Financial Times started out pretty early on, and this is horrible, I'm not remembering the name of the data visualizer, apologies. But the Financial Times had some pretty amazing early on case data out there. So I think those are top two. I just saw The Guardian yesterday unrolled something, but I need to take a closer look at that as well.
I also just want to say that I really appreciate how diligent you are about citing the artists and the designers and citing data. I feel like obviously you're in that world, and so of course you do that. But I guess I'll just share my own bias, which is that I feel like we, you expect to see the name of the person who wrote the article, and I have such a new appreciation for the amount of work that goes into all of the pieces of our understanding, and really realizing that these graphics and these images that I've been consuming are probably, for me at least, more important than the articles that they come along with. I probably spend more time receiving information that way. And so I just really want to thank you for that, and commit to being better myself about that. Also am curious, I guess, getting back to your history with Santa Cruz. And you started with science illustration, which is kind of, you've kind of taken it in a different path, even though that's still there. And I'm curious if you can share just a little bit about that journey, and what is it about data visualization and design in particular, and what, where you fall on that spectrum that you've been sharing with us.
Right. Well, I think the reason I kind of shifted a bit from being an illustrator first and foremost is sort of this interest in being in communicating stories and processes and concepts that I never really thought of myself as a fine artist, so I couldn't tell stories through kind of a beautiful painting in a way that somebody else might be able to. I was very kind of object focused, but I wanted to tell stories, but I didn't know how to do that with just the object. So starting to piece together more than one object together, showing that object changing over time, starts to mean that you need to think about composition and guiding somebody through that, and how they're going to read through that. So I think I just started to get more and more interested in how in composition and how pages are set up, and now how people read through screens. And so I think it just kind of, then data visualization kind of was a natural extension off of that. When I became an art director, I needed to start being responsible for more and more sort of information rooted visuals. It was just kind of part of the package. So when I was working with data visualizers and seeing what they could do, it became clear that that was another way to kind of think about how to use a visual language to tell these stories. I guess that visual language just got more and more abstract over time. Started out very literal and representative, and it just got more and more abstract.
Yeah, I mean, it seems like you've had to learn so many new tools for that too, and it seems to me like so many people, they get into the arts because they're drawn to a particular medium, possibly, or one appeals to them more than another, and the act of pen to paper is so different, I'm assuming, than a lot of how you create images now. And so would you say that the drive was more that narrative, and an attraction to visual narratives more so than the tools that you're employing?
I think so, because also quite honestly, I don't use a lot of the tools that I was highlighting, in terms of I don't work. I dabbled a little bit with 3D programs. I dabbled a little bit with coding, but I'm not proficient at all. So I think as my role became more and more like an art director and a project manager, it became just so liberating and wonderful to find artists that you're you have this vision in your head, and you're oh, this person can do it. And do it better than the way I'm imagining it in my head. So I'm going to hire that person and communicate to them my goal for this. And maybe I have a really specific idea, or maybe I just have an outline of an idea, and then work with them because I know they can do it better than me, or with a different or just with a perspective that'll feel fresher and more interesting, or I'm stuck on something and this person has the ability to problem solve that out in a way that I can't. So a lot of that has just been dictated by me becoming more of an art director and less of an illustrator, I think. Yeah.
And it sounds also like, I know that there are so many people joining us who are in this line of work in one way or another. They're either in school, studying science illustration, or they work within data visualization, or they're artists, or and so it sounds like there is a place for all of these different specialties, and that while you do recommend being like understanding all of the different sides so that you can best like collaborate and think about the possibilities of how best to tell a story, that that you do have people on your team that do specialize.
Yeah, yeah. I mean, we work with a lot of freelancers in particular, but I do think mostly I just like the idea of being aware of how different, how to problem solve things in different ways, and how to take inspiration from areas that might not be exactly the same, but kind of they're solving a lot of the same kinds of problems. And so maybe we can just kind of learn from each other a lot more. Yeah.
And kind of hearkening to that sentiment too of just everyone who's joining us, and how there are some people who are joining us from the who are in the exhibit that we have on display right now, our virtual exhibit, which will eventually become a physical exhibit once we reopen. Would you mind if I share the poster image from your?
Oh, sure. No, this is funny. I'm sorry. I just hit my microphone here.
Is that okay with you?
Yeah, you can.
Okay. So this is, it's not the best form of showing it. I just pulled it up, but this is the poster from the 1996 Illustrating Nature show that was held at the Santa Cruz City Museum of Natural History. We had a different name when we were run by the city. Now we're a nonprofit organization, but you actually contributed to this poster, did you not?
Yeah, I drew the moon on scratchboard. So that's a classic scratchboard, you know, whiteboard with black India ink on it. And then you take a stylus or an X-Acto knife and scrape away. And I believe, I should have double checked, but I'm like 99% sure that Rick Jones is the artist who did the Nautilus illustrations at the bottom. And I don't know, I think somebody from the museum composed the poster. But that moon scratchboard piece is still hanging on the wall of my parents' house in California. So
wow. I just love that. And I just have to say too, for this, I find this to be fascinating, but the way that this happened is that I was reading an article that Jen wrote that was the basis for this presentation, researching for creating exhibit labels for this Art of Nature exhibit for this year. And had no idea that Jen had this history with us at all. And also we just like confirmed a couple of days ago that she was in this show, and that found this poster. So I'm really loving the kismet of this.
Yeah. I was convinced when you reached out, when I heard from you, I thought, oh, she must have talked to somebody at, you know, Monterey Bay who was at Santa Cruz, and they were like, oh, you should. But so that's really funny.
It's just
yeah.
Great. So yeah, I guess one other thing that I just wanted to bring up, that I was having a conversation with a colleague about, you know, our interest in this subject matter. And she brought up a project that she had seen at some point where someone specifically, they were mapping out, it was like kind of a heat map, and they specifically inversed the colors chosen of like warm was blue and cold was red. Do you have any, like, I don't know, is that something that comes up in your world a lot, where people play with visualization in that way, or try to confront some of those modes? And also, like, do you have fun with that at all, or do you use data visualization and graphic design and illustration in areas outside of the magazine, and maybe even outside of science? I know that was a lot, and I'm just kind of curious.
Sure. Well, to start with the kind of the plane and the, you know, like swapping color and that sort of thing, my general instinct is if color is like kind of intuitively telling somebody something, to like work with that and use that. So generally I would go with, like, you know, the hot red, cool blue. However, that's also very culturally based, right? So that's what I think. But I don't know what a lot of other cultures think on that matter. So maybe, you know, so it probably really depends on the specific thing. But someplace where I'm trying to flip that, and I think a lot of data visualizers are confronting this too, is when doing a gender-based data with male and female, to not default to the blue pink. So it's hard to step away from, because, you know, people will intuitively, because at least in certain cultures, we've been brought up to think of blue as male and pink as female. But to try to like flip, to kind of get that out of people's heads as like this binary kind of like set in stone thing. So so I think there's been a lot going on about in terms of trying to figure out different ways to use color to not reinforce kind of stereotypes, but it's complicated, right? Um, so if and so far as using data visualization and things in the rest of my kind of life, um, yeah, I probably keep a lot more like, you know, visual like records than a lot of people do, you know, whenever I'm like trying to make sense of the world on my own, just kind of on notepads. But I also tend to just, well, I know we were talking a little bit before, and then you had noticed that I had a kind of an obsession with the Joy Division Unknown Pleasures album cover. And so sometimes I'll go down these crazy rabbit holes where I'm like, that's a data visualization. And somebody told me once it appeared in Scientific American in 1971,
Oh, wow.
before the Unknown Pleasures album came out. So I tend to go down rabbit holes that take up weekends and evenings, kind of following paths like that and doing, trying to figure out what the data visualization really shows and all that kind of thing. So yeah, work kind of spills over into non-work stuff
This is the best
for me.
this version of it for y'all to
Yeah.
see. That's what we're talking about. But yeah, I think that's also like a fun thing to note is that not just uh, data visualization doesn't exist only within the realm of science. Like it kind of seems like it's a science practice, and so therefore it's like inherently associated with science.
Yeah.
But artists
Totally.
and like you can, if you think about Greek mythology, like you can use data visualization for, you know, the occurrences of something in Greek mythology, or I don't know what else. Like, does anything else come to mind of like kind of a little bit more off the wall?
Absolutely, yeah. And actually, I'm seeing a lot of good folks doing some shout outs in the chat. Dear Data, hand-drawn postcards from pen pals. Stephanie Posavec and Georgia Lupi sent each other every week a postcard where they handed their own, you know, they asked a question and that they would be observing and taking data on over the course of that week, and then they'd mail it to each other. So check out Dear Data. That's kind of one of the biggies. There's so many out there. I'm seeing who else. I think I saw somebody else post another one here in the chat.
Sketch.
Thank you for putting things in the chat form, folks. This is great.
Yeah.
Data Sketches, that's another one with Nadi Bremer. And yeah.
Data visualization, storytelling. That's interesting too. Yeah.
Yeah. But I think there is this pendulum swinging, like I think it mirrors a lot of what was happening in illustration. Illustration, there was a lot of hand-done things, and then the computer kind of took over, and 3D kind of work was really popular, almost to the point where artists were letting the computer make decisions for them in some ways. And then we kind of swung back towards artists kind of, you know, not just, you know, are doing kind of more hand work on things. I think the same thing happened with data visualization, where we're kind of coming back towards some folks are doing more kind of hand tooled and handcrafted data visualizations.
Yeah. Gosh, there's just like, so I want to keep talking to you more and more. Another thing just popped in my head, but I feel like we should probably start wrapping up. But before we do, I just wanted to share also some other resources for everyone watching. So these are a list of resources that I'll send out in an email to follow. And so we've got the virtual exhibit that the museum has available online right now, The Art of Nature, which features 38 different artists from the general San Francisco and Monterey Bay areas. There are 30 or 52 pieces of science illustration in that show. There's also the Illustrating Nature virtual exhibit that is with the students at CSUMB, which is the original show that Jen was featured in back in '96. We also, on our website, have been partnering with some of the artists in the show to create activities and prompts, and for them to share their perspectives and content through something we're calling the Art of Nature at Home, so you can explore those resources. One of the artists in the show, Andrea Dingeldine, also works with the Science Illustration program at CSUMB and with the Illustrating Nature exhibit, and she shared with us a lecture that she gave at the museum last year that's called Exploring Science Through Art, which is about the history of science illustration. So that's something you can watch right now on our website. And then there's also the article that this presentation was based off of that Jen's updated for us, but you can go through and read through it too, that we'll share with you. And then we also just, we'll continue to have events. We have weekly geology events, Jen, which you might be interested in, with two geologists who are working on their PhDs at UC Santa Cruz currently. And then also our collections manager is going to be diving into our malacology collection, or shell collection, in a week or so. So lots going on, so stay in touch. I've linked to our newsletter, so all of y'all watching can continue to, find out what we've got going on. And again, I'll send out an email. It's gonna have all these resources. I'll also add the links that Jen had in her presentation. And yeah, stay in touch, become a member, and thanks again for joining us for this. Jen, do you have any final words?
Just thanks so much. This has been a real treat. Thank you.
Great. Okay, so thanks again, everyone. Enjoy your evening, enjoy your weekend, and we'll see you next time. Bye.
Bye.